What's up? What's up? Just 50 JP in the house. GS 350 JP in the house. Okay, so today's video is going to be about uh, how I think a 3-year-old child could have created trigonometry. Ho, 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 ho. And yeah, so I want to talk about that. If you thanks for watching my videos all the time. Wow, I wonder if you guys can hear me. Let me check something. Hold on. Da, 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 da. No, 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 no. Okay, I'm back. Sorry about that. I had to make sure my what you call it was on. Okay, so I'm just kick back and chill. So yeah, thanks for watching my videos. If you like my videos, please subscribe down there, I believe, and click the notifications down there. And I appreciate any donations or anything that you feel free to give. Um, in my videos, sometimes I'll ask questions. If you answer, send you $1 or whatever, $5 or whatever, depending on what it is. Okay. Also, I'm going to put in the descriptions where you can make donations and stuff, and PayPal, and also, what's that thing called? PayPal and Bitcoins. Okay. So anyway, let's start mathematics. So I made a video earlier today about mathematics, and I just want to give a little story before I jump into this, and about math, right? So it was a friend from Venice, and uh, he's really knowledgeable about a lot of things, and so basically, I was telling him how mathematics is really basics, because he's like, I'm thinking it's this mystery stuff and all that. And so I told him that math is really easy, right? Because it's based on the number one, just a unit, right? And I said, if you really think about it, the number one is such a basic number, okay? And with that number one, you break it down to the fractions, and then you convert it to decimal points and percentages and all that. But you're only using those numbers between, the origin, which it would be 0 to 1. That's it. Everything else is just a different kind of combinations and mixes of it. But that's it. And so I was talking about telling him that units are just mathematics is just a unit of one. It could be your name is a unit. Um, a car is a unit. Uh, of course, composed of different parts. Um, a hand is a unit. Hello, how are you? Just do 50 JP in the house. Got to do my introduction and stuff. I always forget to do that. Okay, uh and that's it. So we were talking, he had his comments and stuff, and I said, just think about it. If you can just if I mean like if you think about it, the number one is a really basic number, right? And it's just a unit. But with that number one, we are able to create all of this other stuff with it, right? With the units and stuff, mathematics, the discoveries, calculations, weights, wind factors, quantum physics, whatever. It's all based on this number one, right? And I said, just imagine if just the number one gives us all of this technology, that you can make just because of the number one. Just imagine, and this is like that would be the most basic uh, math that there is. And I said, if you can create that, then just imagine what the other higher levels of mathematics would be based on some other kind of uh, whatever you want to call it in another dimension or even in this dimension, you know. And when we were talking about, he was like, "Wow, that's really interesting," you know. But I mean, it really is. Okay. So anyway, let's talk about this my story. Okay. So I was telling him how I think how I thought what is the thing called? Hello, how are you? What's up? JP in the house. Thank you for the view. Please chime in if you want. I told him about, I think, trigonometry. Okay. Trigonometry is really basic, simple uh, mathematics, form of mathematics, right? Because it is based off the number one. And I told him that even a child, I said, I bet a 3-year, I mean, I'm just joking, okay, it's right. But I said, I bet you a 3-year-old kid probably created trigonometry, and then some adult saw it, what the kid did, took it and ran off and did their own thing, you know. And he was saying how. So I said, you know, if you have a child with the has a string, right, and the child is outside in the dirt playing, and you know, he's taking the string and dragging it along the ground and making snake moves and snake shapes and triangles and whatever shapes that child wants to do, whether they know what the shapes or not, you know, because you can manipulate that string. And then for some reason, the child take one end of the string, tie it around his finger or a stick or whatever, but I'll just say finger, and put it in the dirt. And then stretch the other side out and then pulled it all the way around, or maybe use a stick and walked around or whatever, you know, holding the rope. And then when he got to the end or the beginning of the circle, when he made a complete revolution, the kid would take the stick or move his finger out. Hey, two people in the house, thank you. Please chime in. Thumbs up would be appreciated. And the kid would take the string and the his finger out, or you know, the stick or whatever, and what would be left would be a circle with a dot in the middle. And the kid was like, "Wow, that's really cool, right?" And so you know how kids are really curious. So the kid would take this string. Let's see, let me get something. Okay, let's say like if this is the string. Okay, even though it's long, but let's just say it's this long, right? And this kid would take that string and put it on the circumference of a circle. So they would put it here, and then at the end, put a little check, and then again and again and again until the kid can't put any more. Of course, until he goes a complete circle, right? And the kid would count 1, 2, 3, 4, 5, 6 plus some little space over, you know. And the kid was like, "Wow, you know, that's really cool." So basically, what I'm describing is the radius, right? From the center of the circle to the circumference of the circle. And then as the kid took that radius and see how many times that they can put it on that circumference, it will be 6 point whatever, whatever it is. And that would be the radian, because the radian is actually the um, measurement of the radius on the circumference of the circle. So there would be like 6 point whatever radians. A radian is a unit, okay, that is on the circumference of a circle. The radius is just the line, radius, radian, right? And so 1 radian is a unit. So in a circle, there'll be 6 point whatever, whatever. So then the kid takes that circle, and from the dot, it would make a, okay, now I can use this, right? The whole thing. So let's say this would be the string, half of it would be the radius, and they would take the string, put it directly in the middle of the circle, right? And then take a stick and draw a line, and then do it like that, perpendicular, and then do it like this, like this, like this, like this, like this, and just draw many lines. And the kid was like, "Wow, you know, all these lines and stuff." So then, of course, the kid would try to count how many, right? And of course, you know, maybe I don't know how many he'll count up to, but I'm sure the kid, if he got time, he'll just do it many, many, many. And there'll be like hundreds of them and stuff, right? And then all of a sudden, a what is that? A parent probably walked by, or some adult walked by, saw the diagram on the kid on the dirt and looked at it and was like, wow, that's really interesting, you know? And then if you know anything about trigonometry and a clock are the same thing. You have 360 degrees on a clock, and if you take how many 1 minute is 60 seconds, you got 60 of them. So it's like 60 times, what is it? How did I do it? 1 minute, 60 seconds, so like that, six times 60 or something, it come up to 330. You can 330 days or whatever it's called. However, I forgot how I said it. There's 60 minutes. Well, 60 minutes and then 60 seconds, that would be 3,600 seconds. So that wouldn't work. So I'm thinking maybe the kid or the adult just use 360 days, whatever. I mean, it really doesn't matter, right? Because any number, it still would come out to be whatever it would be, so it doesn't matter. But let's say somebody used the what's that thing called? The year calendar instead of 365, just 360, make it even, right? So you have these angles, which are 360 angles, and they would be called degrees. Now, the difference between a clock and a trigonometry is, what is it? Uh, ah, yeah. So I said days. Hey, what's up, homie? Richmond Pullman in the house. I'm sitting here talking about math. I like math. How was your week? And so yeah, so it would be a year, 360 days or whatever. And of course, the story. I think they said back in Mesopotamia or something, they use 6 times 60 or something like that. I forget exactly what it was, but you guys know that. I don't. I forget. And so basically, what you have is you have a calendar of 360 days. You have the circle 360 angles, right? And if you know anything about angles, they're measured in degrees, minutes, and seconds. So what does degrees, minutes, and seconds means? Well, it's time. So the degrees, the days would have changed to degrees. Then in each day you have minutes and you have seconds, right? And so the person, of course, they got the six and they measured everything. They measured everything, right? And I guess they got a better calculation and stuff, come out to whatever it is. Then you divided that by half, and that's pi. And then he divided 360 days, which 360 degrees is going to be 180. And of course, we always use pi over 180 or 80 over 100 pi. Huh? You about to sleep? Ugh, I gotta move to another location. Yeah, okay. What? Oh, I don't know what she talking about. So I gotta move to a different location. See, that's what's bad about my live videos. They're always so spontaneous. You know how everybody else, they got the mics and they got a nice background. My videos are on I guess you might say low budget or something like that. So anyway, what it is you have 360 degrees, 360 days, you got the minutes and the seconds. And all they did was just take it, divide it up, degrees and all of that stuff. And pretty much that's what trigonometry is. So a lot of people say like they have trouble with trigonometry, but trigonometry is really easy. And that's the only math class I ever got an A in without really even studying. And the reason I got an A in it is because what did I do? Oh, I answered most of the questions in the class. So actually, this is what happened. I got a 85 on my test because I always messed up on my test because I'm always rushing through it. But because I answered like 95% of the questions, and it wasn't like I just answered them. I answered them in a way. Well, what's the lighting? Let me see. It's not in front of me. Okay, sorry. Wait, let's see if I go this way a bit more. Wow, a lot of junk over there. Wow, let's see if there's anything important over there. Nah, it's okay. But still too light. I need you to go into another. Maybe I should go into another room. Can we go into another room where the lighting's better? So anyway, um, wow, it is like totally dark out here. Hold on. Okay, so let me see. Ouch! Ugh, I hit my toe. Okay, let's see. Is that better? Okay, yeah, that's better. Okay, so basically, uh, I answered like 95% of, hey, what's up, three people in the house? Hello. Thank you. Thumbs up would be appreciated. And so basically what I did was I answered like 95% of the questions. So, yo, what's up, Marcus? Marcus in the house. Thank you for the thumbs up. If you got any questions, please ask. So basically, I answered like 95% of the questions. I do that in a lot of the classes. And it's not because I want to be smart, but the teacher sometimes stumbles, or some classes they ask the students to answer the questions, and a lot of students can't explain it in a simplistic way. So I'll just answer it and then explain it and give my points and views and stuff. So trigonometry is based on the number one. You have the radius. In trigonometry, they would call that the tangent. Do you guys know what tangent means? I would send you $1 if you can answer the question, but it's too easy. I'm sure you guys know what tangent is because we always use it in the language. But tangent is where the a line or some object only touch one part. One part of it is touching. So the what is it called? If you have a radius, then the radius from the center of the circle to the circumference is a tangent, because tangents only touching in one place. But if you fill out to a whole diameter, because it's touching in two places, it's not a tangent, only in one place. And that length would be one, because like I said, everything is based on number one. And then let's say you have a right triangle, 30, 60, 90 degree right triangle. Well, when they do cosine, tangent, and theta, basically what they're saying is what percentage of the those lines are what percent of the tangent, right? So you have 3, 4, 5, or whatever you want to say, whatever it is, and you do the cosine and all of that stuff. And basically, it's just I think it is just, I think I could be wrong, but I think it's just a percentage of the lengths. That's all. So you have the tangent. You got this here, you know, 25 and the 5. What's the percentage and all this stuff? But basically, when you're doing trigonometry and everything, you're just dealing with fractions. That's all. You know, fractions are numbers that's greater than one. I mean, greater than zero and less than one. And that's it. So let's say like you have what else called measurements. So you only have two measurements in trigonometry that I can remember when you're going from it, because everything is based on angles and degrees. The angles and degrees. Wait, not the angles and degrees. The the length of the what is that thing called? The length of the circumference and the degrees of it, because they're all the same, and there's a correlation. So basically, 360 degrees is equal to 2 pi. 2 pi would be 6.1 something, or 6.2 something, or 4 something. I forget exactly what it is. And because you can divide them both um, in half, and then of course you got the pi 3.145 or something like that, 451 or whatever it is, and then you have the 180. So basically, hello, basically what you're doing is you're just converting back and forth. So let's say like you have 180 degrees, you want to know the radians. So you have 180 degrees, which is a straight line, and you want to know what's that, the length of that curve, because you already know that a full circle is, well, half a circle is pi, and then half the 360 is 180 degrees. And so you'll take that and you have 180 degrees. You want to know what the radian is. Then what you do is, well, it's going to be one, so I shouldn't use that. But let's say like you have 90 degrees, can you want to know what the radian is? Well, what you do is because whatever number that you want, you put that on top. So it's going to be radian over 180 degrees. I mean, pi over 180 degrees, or pi radians equals to 180 degrees. So the pi is a number of radians over 180 degrees, 180 degrees. And those are always going to equal to 1, okay, because it's the same thing, but the shapes are different, but it's the same thing. And then you divide it by 90 degrees. And what's going to happen is the degree and the 90 degrees and 180 degrees in the numerator, they'll cancel out, right? And then you'll just have do the multiplying, division, all of that stuff. And it should come out to like 1/2 radians or something like that. But basically, that's it. So if you guys have problems with trigonometry, go back and really go through it because all you're doing is messing with what's that called? Fractions, and they're always going to go back to the number one. And they have all these like they'll have like I think it's called A and B. You got the degree and the radian or something like that, and they're always trying to make it even and stuff. It always don't always equal to one. It really doesn't equal to one based on the way it's done, but it's close enough to where you can say it's one. 9.99989 or whatever, or whatever it's going to be 9. So I wish I had a pencil here. I can give you a design. But if you're having problems with trigonometry, go back. It's really a fun subject. It really is fun. Um, you can do geometry, play with the angles and stuff. They got apps, you just really, like I used to play this one angle app and stuff. And it was just really fun, you know, to actually go over it and say, okay. Oh my God, why didn't I pay attention? And it's just really cool and stuff. And like I said, trigonometry basically is just dealing with pi over radians or radians over pi. The pi radians, it's pi radians, so pi over 180, but pi radians, pi degrees, and those are the radians, like I said, those are units measurements, so it'd be like inches over feet or something like that, you know, and just go back and try it. I mean, it's really easy and stuff. Calculus, oh, I was talking to, I think I was here another time. I was talking to a guy and we was talking about rates of change because a lot of people actually make mathematics, the way they describe it, harder than what it is. A rate of change is just a fraction. That's all it is. X over Y. If X is 1, Y is 2, 1, 2, 1, 2, 1, 2, and it's always going to be that same thing. And basically, it's a slope. A slope is a line. But like, what's the rate of change for X? Well, it's 0 because it goes straight and it's not going to change. What's the rate of change for the y-axis? It's going to be 0 because it doesn't change, or let's see, yeah, it should be 0 because it shouldn't change, you know, and then you have an angle, so it'd be the x and the y, and it's just, just simplify the mathematics and stuff. I mean, the fractions and all that stuff, and you'll get it. And it really turns out easy. Okay, now I teach, well, I have a question. I was thinking about making these videos going around and teaching, talk to the parents who got little kids like 5 and 6 years old. I mean, 5 years old, well, actually between 3 and 5. And I used to do this on the train to say, hey, can I teach your kid how to multiply or divide, or both? It depends on how much time I have. It take less than 10 minutes. Get a piece of paper, whip it out, show them how the kid do it themselves and stuff. And, you know, if the kid can do it, pay me $10, $100, or what, just make a bet, just really make it really fun. So I was thinking about making videos like that. But the only bad thing about that would be because it's so simple and all the kids do catch on. I know I'm repeating myself, but you know, somebody's going to get a hold of it and then write a book and stuff, and then make billions of dollars because it's crazy easy. And like I said, I have it where it can go from teaching multiplication, division at the age of 3, and by the time they turn 5, they can start algebra. Basic algebra. I mean, it's really cool because algebra, you're just dealing with different numbers and you're just playing with numbers and stuff like that. Algebra can be challenging. Geometry is definitely challenging. Trigonometry, based on the basics and stuff, you can start making a massive amount of math lessons on YouTube channel and do a separate channel based in math and stuff, make more money with subs and stuff. Yeah, no, that's what I was thinking about doing actually. So, because I already have like a whole bunch of different channels. So I wonder, math with GS350JPN, something like that. But I don't know. I just keep everything on this channel. But I do know if I want to make some money, I need to do that. But I really should. Maybe I should write a book or something. I'm not sure. But yeah, that is a good idea. Because actually, I started this other channel, um, chatting with GS350JPN, CWGS350JPN, and I made that with this one sister, and we were supposed to just ask people on Facebook, whatever, to go do some videos with us and just talk about different subjects and stuff. But that of course that fell through. But yeah, so I guess that's it. So if you trigonometry, you guys really should um, really try it again if you think it was difficult. The whole thing is it's just vocabulary. But the sine is always going to be a vertical line. The cosine is always going to be a vertical line most of the time. Or just you got the cosine. I mean, what's that? The opposites, cotangent and all that stuff. And those are just reverses, something like that. But the basic is make the channel look real pro looking with the intros, videos, and all of that. Yeah, I know. I need to learn how to make intros. So because this channel is terrible, no intros and nothing. So I'm gonna have to figure it out. My friend, he made a good one. That was really cool, but he studied. It was really cool. His one that I filmed and everything, and he just took everything and just it was really awesome. Um, yeah, I really have to do that though. But anyway, I got a couple of minutes. I only just want to make this 30 minutes. Go to sleep. Uh, so what I'm gonna do though, I want to try something. What I'm gonna do is I'm gonna start going to Osaka when I get a chance and just sit down, have my little thing, my little setup here, and just make live videos and stuff where a lot of people are hanging out and maybe some girls come over and talk and get an interview. I don't want to do that because now I've got this 24-hour, 50 gigabytes. I pay a lot of money for that, like 60 bucks or something. The video quality is really good. Oh, this video quality? Oh, thank you, thank you. Um, what is your setup? My setup is an iPhone 11, iPhone Pro, huh? iPhone Max Pro, huh? iPhone 11 Max Pro. That's what I'm using. Just that's it. This is my iPhone. I think I have it on 4000 HE. Yeah, that's all. That's all I've ever been using. I think my first videos, when you go back, go to my channel, you look at the old ones. Those was like a 180 hard drive and stuff. I still got my old videos, but once the iPhone came out, I just used those. And yeah, the quality has always been good. People ask me, you have JVC? Large screen light would make things better too. Okay, then do me a favor and send me a link to one, and then I'll buy one immediately. You mean got it in the background or in the front? I forgot where would they go. I guess they would go in the front, huh, to make my what you call it better. Hmm. That means if I go on the street, I have to find a sunny place, right? Okay. I got like 30 seconds. So anyway, I'm gonna go. I gotta work tomorrow at 12. This little kid, he started my class in January. Trial lesson. He learned to use a dictionary in a trial lesson, 20 minutes. 20 minutes. He's the fastest kid I ever. quickest one I ever learned to. I mean, can fully find words in 20 minutes. I couldn't believe it. And he memorized my phonics course I have. He only in 2 months. I mean, 6 weeks. That was it. The lightning ain't scared right now. So if you get it, green light goes behind the phone. Oh, okay, okay, cool. And in 6 weeks, 2 months, because he only comes 3 times a week. I mean, 3 times a month. And 6 classes, he passed my phonics. So now I think we just finished. He did the action verbs test, be verb test, and some other tests, and test. He finished that. So now I'm teaching him how to make sentences with verbs and stuff, and he's doing really good. And the reading too was awesome. I mean, he is really fast. So, but anyway, I'm supposed to be talking about now, so let me stop tripping and stuff and going off into different things. But I got to go. Thanks um, for. Okay, thank you. Yeah, thanks, Marcus. And I'll look into that. If you can send a link, cool. That would be cool too. Send me to my YouTube, not my YouTube, my what you call it? What's that thing called? Gmail address, GST50JPN. Okay, I'm out. Take care. Peace.